Welcome back, everyone. Here's another edition of looking at New Boston for VR resources. It's going to be a long next 4 weeks, 30 days-ish until we get the assays. And the market apparently is very impatient. As you can see at the top right of the screen, we're down to 5.5 cents. I do not predict share prices. I just look at projects, see where we're going, what kind of value gets added, what type of opportunities, and mostly I look at the market cap and look at where that market cap could go. And I don't look at my share per position as a whole. I look at what is your percent ownership in that market cap? What's the upside for you? Can you own 1% of a company? Can you own 1/10 of a percent? Can you own 1/3 of 1/10 of a percent? Those are basically leverage percents that you can get into a project. If a company goes from $1 million market cap to $100 million market cap, then you're like, if I own 1/10 of a 1% of $100 million, that can be life-changing money for someone. Versus, oh, I just own X number of shares at 5 cents. You really don't know how many shares is outstanding. What is the upside? So that's kind of how I look at it. But yeah, it's going to be a long, 4 weeks until we get some of the assays. So today I thought, instead of talking about geology, instead of talking about the minerals from a mineralogy point of view, instead of talking about accounting or math, which I'd love to talk about, I'm going to take a step back and talk about chemistry. Something that we may not get from any company in the junior sector. I'm sure if you send questions on chemistry to the CEOs or the geologists, they're happy to answer, but it's not something that they go and, if you're looking at an investor pool, they may not think that, the basic sciences are needed or effective at that point. But for me, I look at this, this project, and I'm like, okay, well, we have some visuals. Maybe the market doesn't like it. Maybe it's impatient. And we have some words in those visuals: sulfides, dissemination, chalcopyrite. Some key words that are, sound great to me. Visually, though, it's just like when you see black, you see money. When you see a black spot, that's where the money is. When you see a black line next to quartz, that's where the money is. And do you have enough money to, make a mine in the end of the day, right? But I'm like, well, why are we looking at black spots? Okay, molybdenum. Why are they all black spots or black lines? Copper. Why do they also happen to be black? It's just like everything just seems to be this black spot. So I'm just like, okay, well, take a step back. I'll go, okay, we have sulfides and oxides. Well, what does that mean? Okay, so if I look at copper and I'm go, okay, what makes copper green? Okay, you take your sulfides, it gets exposed to oxygen. Is that what makes it green? Does that make it an oxide? Is an oxide green? Okay, and these are questions that maybe many of you also have. So it's good to take a step back and then just look at the chemistry. What does oxidation means? What are the different oxidation states? Why, when we see core, if we see black, that's copper of some sort, or it could be moly. I haven't even looked at silver yet, so we're not going to talk about silver today. We are going to talk a bit about pyrite, because chalcopyrite good, pyrite bad. So we're going to look at that to kind of compare that as well, because it is involved. One of the photos that I like, it was actually one on Facebook that they posted, is this photo. I look at this in photo, I'm like, yeah, this is kind of why I'm investing here. I see some quartz, I see some type of mineralized zone, but I definitely see the green. And from a public relations point of view or promotional or something like that, it's just like, I see that green staining. I see that that's, we know there's copper in there. We don't know how much, but we're guaranteed if you were to send that away or get it tested based on what we know in the area and the fact that we have that, the green area. Um, that's what I see. If I erase all the green from this, from this quartz here, and I go and edit it. So just imagine the green is gone. Now, if I were to, put, drill holes through here, I can absolutely visualize some of what we were seeing in the drill core could be something like this. That quartz with some of this, this narrow veining here, and a little bit of thicker here, and it's all over the map here with the fracturing. I could totally see this sample here if you remove the green, staining on it. That is what we want. What we want to see in the visuals is we want to say, is it what tells us is there's copper in here? I don't see the green staining. Why don't I see the green staining? So then it got to me. I'm like, well, what exactly makes copper green? Is it like tarnishing? I think that's more of a silver thing. Gold is inert. It doesn't actually oxidize or react to anything, and that's why you can see VG, visible gold, nuggety things in core, because it just hasn't reacted with anything. It was placed in there. It's all good. Now, when you get into things like sulfides and oxides, you have to look at other stuff and say, okay, well, what exactly will it look like? So what else do? I go in Google, and now I'm going to look at the chemistry behind, why does copper turn green? Here's just a website from Australia that came up, and it's got some, pretty basic information into it. We have this nice copper roof here. That would be a great color, to see a chunk of that. This is the raw, pure copper in the deposit. But this is kind of great because it goes through the reaction. So when it starts to oxidize with air to form copper oxide, which I think is kind of the picture we saw, it'll turn reddish pink. I don't know. I guess I don't know if I see that very much, but that is one state. But we know that in a lot of deposits, we're talking about 20 million years, 80 million years, 150 million years, 500 million years, that it is exposed, it is near surface. As you get close to the surface, you get more exposed to oxygen. Copper oxide will continue reacting to oxygen over time. So it totally makes sense that this is where we sit in this deposit, but does it go further than that? So in this one, we get black, and it says this is going to turn black. This is what the copper is going to be. So the chemistry is telling me at this point, if you just expose it to oxygen over a very long time, it's going to turn black. Okay, when does it turn green? So that's the next statement. It says, as the copper oxide continues to react with carbon dioxide, stuff in the air, plus water in the air, it coats it on the surface. So you're getting it wet, you're getting carbon dioxide. All of a sudden you get blue, green, but I don't even know how to say that word, so I'm not even going to try. I'm sure if I heard it, I could repeat it. But anyway, so you can get these, if you see a nice mineral specimen of this, you could see multiple colors in it. In this case, we're just seeing the green, right? So, here we have the green showing here. And then on this case is, we're seeing the all the green here. So this is getting exposed to, air plus water plus making sure there's carbon dioxide in the air, and that's why you're seeing the green here. So we are really stuck in the ground with this black thing. But why hasn't some of that turned green? And I think the thing that's really missing here is really H2O. Okay. Why haven't we exposed H2O, water, to this material, to this core that we've gone through? with this, why don't we get that, that green copper staining? And I think the answer is, twofold. Number one, it helps having all that limestone. Every time water tries to permeate through it, I believe that limestone is just going to kind of, expand and prevent that water really from going saturated into the ground, right? Two, if we actually look at the mountain here in Google Maps, you can actually see all the streams going over toward I believe this is the Soda Spring Valley here. So I assume this whole area was filled with water at some point, but we had this natural runoff, probably eroded some of the stuff here and probably eroded some of the deposits that we're drilling into, I imagine came a little bit higher up as well. So, but yeah, I mean, the water just goes that way, and also that barrier of limestone is just preventing water from getting into it. So I think when they also mentioned that they believe leaching may have not occurred of the copper out of these black spots or these black lines. I assume maybe even if there was that water, we might even see a little bit of green. So if there's no green, no leaching. So in theory, those black spots will be more of the pure, and within them should have high grade minerals in them. So that could explain why the copper's there, why it's black. Maybe people saw some of the quartz veinings, narrow veins with the green, and they chased the veins, but they didn't think of nothing. Maybe they drilled lower and they didn't really see anything, so they didn't even think there was copper there or that much of it. So that's why, so now we've solved why, the copper oxides are going to be black when they're exposed to oxygen, not much water, and CO2. I don't know if that permeates in the top part of the ground or not, but I think water is the key one that's missing here. Plus, we're in Nevada. I mean, how dry has it been for a long time? I think you get the random thunderstorms and the thunder cells, and you get all this electricity happening. Which, who knows if this ridge has changed even that dynamic with the clouds and stuff. Okay, so we see black, could be copper, but we're also told it could be molybdenum. So if we look now at molybdenum disulfide, you'll see in the sulfide state, it's black, a little bit, shiny silver gray. But just looking at it from this point of view, this is what gets produced. This is what's sold for $40,000 a ton. This is what it is. What happens when moly oxidizes? Because we just talked about copper, so we got to do the same thing. What colors does it change? What happens into molybdenum sulfide or moly sulfide, disulfide? Okay, so if we scroll down, this is basically the answer here. Molybdenum disulfide is stable in air and attacked only by aggressive reagents. It reacts with oxygen upon heating, forming molybdenum trioxide. So it is not very reactive at all. I've gone some of these pages and they're like, if you throw 100 degrees Celsius plus oxygen, you might get a reaction to something else. And it basically, with just the heat and the oxygen, you can go to the top one. If you have access to chlorine, you can go to the next one. So if you were to go to molybdenum trioxide, here's a photo of what it looks like. It's basically made in a lab. If you want to use it for whatever purposes, you're going to need heat, oxygen, or other reagents to get it there. And then chloride, it kind of, here's partially oxidized, but as far as I know, there's, I don't know if chlorination naturally occurs, but I haven't heard chloride in relation to New Boston at all, so we're stuck with the sulfides, black. So if you're in a zone with quartz, and some moly's been deposited, and copper's been deposited, and you let it sit there, and oxygen just goes nuts for 50 million years. Copper will turn black, and the moly will stay black. So you actually end up with sulfides and oxides, and that's where it gets confusing because and maybe other people are like that. It's like, oh, we have sulfides of whatever type of sulfides, and if they get exposed to water or oxygen or whatever, they all become oxides at that point. And clearly, we're talking about two chemical elements here, and that is not the case. Copper in New Boston and in these drill holes, the black spots, copper oxides. Molybdenum disulfide will stay a sulfide, and that will also look black as well. So that is why we are left with, if you see black, that's where the money is. And this is where the chemistry comes into. And again, as a speculative investor, and I'm just going to look at a thing, I want to see, like the staining of the green. I want to make sure that there's copper here. We know there is copper here. We can see it at the top where it does get exposed. So if we bring that point up, here, like we'll go back to here. Okay, well, where are we going to see something that gets exposed to CO2? And where are we going to see something that gets exposed to water at the same time? Well, even if it goes down the hill, here you go. So we have this fault, which is absolutely going to, it's going to be weak ground deeper down. So even, further down a little bit, you might get some of this items here. As you get further down, you probably get something similar to what we're already seeing in the drill holes for the east zone. So this just kind of shows you these fancy green pictures that we're going are just basically because of the chemistry and the reactive nature of it. And then I'm like, okay, well, I know chalcopyrite is good. It's got copper in it. I know pyrite is bad. There's no copper in it. What does that become? Is pyrite gonna turn black as well? So the answer to that is no. Here on the right hand side on Wikipedia, the shiny, golden color, fool's gold that you have. There's a lot of iron in this, in pyrite. So when it does change, if you read the articles, there's like 8 different levels of oxidation. But you end up, a lot of it is, you kind of focus on the iron. When you think of iron, I think you think of red. That's kind of what I think. And I think some of those Gaussons that they were talking about on surface do have the redness from the iron. I think the iron staining on the top of our zone, that, it could come from this as well. But when they sampled it, it was also, 0.8% copper or whatever. So I think the red comes more from the iron from the pyrite type stuff, but I think chalcopyrite also has iron, so it could also be from that as well. So yeah, you can look at this. So I'm not. So the intent here is that if you see pyrite, it's either going to be shiny like this, or for whatever reason, if it managed to oxidize itself, it's not going to be black. So I think those black spots are copper or molybdenum. Okay. And then I think when you see the visuals, you're like, in a traditional deposit, or when we have water zones and all that stuff and no limestones above us, well, even if there is some black there, some of the copper, some of the minerals could have leached out and gone elsewhere in the deposit. So you're looking at a black spot, you're like, okay, well, a percent of that could be copper or moly, and the black spots represent a percent of the quartz. So I think when we look at that and we look at this dissemination, I think it's true what they said in the video about kind of the in situ when that copper or moly was placed into there, it really hasn't changed over the whatever 80 million years. It's still in there. The more veining we have, it means the more fluids come up, meaning more minerals. So there's more options to have those, those black lines or those black spots in there. I think in some of the deep down ore, you're actually seeing some of the shinier metal bits and stuff too. So we're undoing the oxidation. So there's a little bit more of that as well. But so I think based on just the chemistry, now that I understand the chemistry a bit more, just going through this, hopefully you have a better understanding as well, that black is money. So we see black spots in the core, we see money. We see the white quartz, that's not money. That's just waste. We see quartz, we see veining, we see black spots next to that. That's where the money is. So that's kind of what I wanted to show you. Yeah, let's see if there's anything else. Now if we talk about, I'm going to jump completely different shifts here. Talk about kind of the philosophy of investing as well. So why would anybody want to invest in VR resources, and how do you get in here? What makes you excited? What makes you have rose-colored glasses, right? Like, so we have to talk about bias. So for me personally, there's two sides to it. You can be biasly optimistic, or you can be optimistic bias. So and why do you own the stock? Why are you here in the first place? So when I think of New Boston and I do all this due diligence, I'm optimistic because I have a bias. I have a leveraged position in VR resources, so you got to take everything I say on New Boston with a bit of a grain of salt. I do like learning, so all this stuff is net new education for me. So even if I'm wrong about New Boston or it doesn't come up to be, I've learned something, and that's great. So that's where I'm optimistically, but that's because I'm biased. So on the flip side, optimistically biased, if we actually look now in this part, this VR introduction here, and I'm going to scroll down to, it's definitely, diamonds are our counterplay. It's like, the world, there's a lot of negative press on it. Deposits are running out. So why would I be, even into diamonds? But I am into diamonds. I'm bullish of the future because I think in 100 years, you're not even going to have any diamond mines. And if you own a natural diamond, great. Might be worth something. So I do like diamonds from the long term perspective. But if you look at this, what I like about this here, they talk about materiality to it. And because I cannot find the words right now, I'm going to do it. Oh, there we go. Okay, so this is probably the gunning influence. The results are material. Finding this Northway Diamond Project, they confirm the prospectivity of what is almost certainly a new and previously unexplored kimberlite field in Canada. They've consolidated a large land position around Northway, around the property. I'm extremely optimistic about this theory, this thing. They need to go drill and go do surveys and prove this out, that they found this, they found a new way of exploring, they know what they're looking for. They prove this on 2 or 3 other targets, it's going to be 30, 40 other targets that they're going to be drilling in the next 10 years. This I'm totally optimistic on. This is why I got into VR resources in the first place, and this is why I'm now biased on VR resources. Optimistic on this project, therefore I'm biased on VR resources because I've established a leveraged position, leveraged for me at least. Leverage means different things to different people. because I have a leveraged position in VR Resources, I now have a bias on New Boston. So why do you own the stock? It's 5 cents now. I watch it regularly because it gives me the opportunity to say, I own this because of this. If it goes down further, maybe I'll buy more. That's basically why I watch it a lot. Otherwise, if I was happy completely with my position and I'm not looking for opportunities, shut off the internet for 4 weeks. Let's see what the result is, and let's move on with New Boston as well. So yeah, so that's great. Now, I said I wasn't going to talk about accounting or math, but I will talk about accounting. So the company did receive $1 million recently from their rare earth project sale, and they get, I think, shares or something over time. And they have some money in the treasury, I think, still left because New Boston was really slow drilling, but the original contracts, I think, were based on meterage, not based on time. That will change in the future. I'm sure they paid a little bit more for the thicker drill core. But the accounting in me is just like, this is in Canada, Northway. They still have things that they're going to do in Nevada. They still have plans there. They still have plans in Ontario. With Ontario, with this work, this can be flow through financing. So I believe currently, from an accounting point of view, their treasury is basically hard dollars at this point. And that's why you go to US investors and do a financing, bring those in, do that. Now you go to Canadian investors at some point, maybe this fall, if they're going to do some magnetic surveys, do a very small raise in Canadian funds. Hopefully, the price is much higher, and then they can do that to do that. So that's just a little tweak on when you say a junior company has money in the bank. That there is a difference between Canada and the U.S. So we just have to be aware of that. So I could see a small flow through financing happening in the next 3 to 4 months. I don't think they'll do it before we get the assay results, but we'll go from there. So again, I'm optimistic. I'm like, why is black where the money is? Now I know. Now I know. I can look at the chemistry. I know you can have oxides and sulfides at the same time with two different minerals. I know all this is, this is true. So let's get this done. The other comment I have is just thinking sometimes you got to think economics. Sometimes you have to think practical. So if I think of moly, this MOS2 might be the more in situ. So if you see black spots, it might be all MOS2 and not much else. This is the product that gets sold on the market. This is the product that gets sold for, $40,000 US per ton. Okay. Copper, let's say it's chalcopyrite. It's turned black because of the copper is turning black. There's 66% of copper in chalcopyrite, something like that. Copper is the end product. That's $10,000 per ton. So the economics in me is like saying, oh, maybe we'll get more moly and maybe we'll get more than 0.5 copper EQ or higher, because if we see more moly representing the same space of those black dots, then that makes sense more from more economic point of view. However, when I think about it, probably in Nevada or that part of the US, I'm going to think that there's a lot of places to help process copper, refineries, concentrators, all that stuff. So from moving a project forward, there's probably going to be a lot more opportunities to process copper than moly. I know Rio Tinto at Kennecott, huge copper skarn part of originally a porphyry. They want to recover as much moly as they can. They actually do have moly in it, so they go that extra mile. That's more from a make sure we get everything out of the ground, process as much as we can, and basically be good citizens to not, waste material, do things in, a very green environment, let's say. So there are still options if this is, a moly predominant things, but yeah, so that'll be interesting as well. So let's, go for, copper, at least in the top bit of, the drill holes, and maybe if there's more moly, the economics will change. Still a big question. They didn't get deep enough, I think, to hit some of those magnetic targets, but that magnetic stuff brings in even more chemistry. What minerals are there? What makes it magnetic? I don't think we're going to get an answer to that. But to dig deeper with the drill hole, it'd be interesting what the next, 2 years of this project is going to be. Because I don't think they can just drill through that material at that speed. If they want to get deeper, maybe they have to go purposely through, some more waste material to get down there to do that from a different angle. But we'll see as we go. So I've rambled on enough. But yeah, I'm sure I'm going to learn a lot more as we go as well. But that's just a tiny bit of chemistry.